Hey everyone, welcome back to our channel. Today we're diving into some of space's strangest and most unexpected discoveries. Not the usual stuff you hear about, but the really weird and wonderful ones. Alright, let's kick things off with a truly one-of-a-kind planet, 55 Cancri A. This planet isn't just any ordinary exoplanet. It's often referred to as the Diamond Planet. 55 Cancri A was discovered in 2004, and it's located about 40 light-years away from us in the constellation of Cancer. It's part of a 5-planet system orbiting a star named 55 Cancri, which is visible to the naked eye under the right conditions. But what makes 55 Cancri E stand out is its composition. 55. Cancri E is often called the Diamond Planet due to its unusual makeup. Based on its density and other characteristics, scientists believe that this planet might have a substantial amount of carbon. This carbon could form a diamond under the extreme pressure and heat conditions present on 55 Cancri E. Imagine a planet where vast stretches of its surface could be sparkling with diamonds. It's an incredible thought. So how did 55 Cancri E end up like this? Theories about its formation suggest that the planet might have originated in a carbon-rich environment. As it formed, the high carbon content, combined with the intense heat from its star, could have led to the creation of a diamond in its interior. Astronomers and scientists have been fascinated by 55 Cancri E because it challenges our understanding of planetary formation. Many of the planets we've discovered so far have compositions similar to Earth or gas giants like Jupiter. But 55 Cancri E shows that there are many more possibilities out there. It's a reminder of just how diverse and surprising our universe can be. Next up is something straight out of a sci-fi movie, the giant space blob, also known as Lyman alpha blobs or labs. These are some of the most massive and mysterious objects in the universe. Lyman alpha blobs or labs are enormous clouds of gas found in the distant universe. They're named after the specific wavelength of ultraviolet light, called Lyman alpha, that they emit. These blobs can span hundreds of thousands of light years, making them some of the largest structures known to us. Labs were first discovered in the late 1990s, and scientists were initially baffled by their sheer size and luminosity. These gigantic clouds were shining brightly in ultraviolet light, but there was no obvious source of energy that could explain their glow. The scientific community was both excited and puzzled by these discoveries, as they didn't fit into any existing models of cosmic structures. So, what do we know about labbies now? There are several theories about their formation. One idea is that they're regions of intense star formation, where young hot stars ionize the surrounding gas, causing it to emit Lyman alpha radiation. Another theory suggests that the blobs might be powered by the activity of supermassive black holes at their centers, which could heat up the gas and make it glow. Despite these theories, labs remain one of the biggest puzzles in astrophysics. Their sheer size and the energy needed to make them shine are difficult to explain with current knowledge. Scientists continue to study these giant space blobs, hoping to uncover more clues about their nature and what they can tell us about the early universe. So labs are a fascinating reminder of how much there is still to learn about the cosmos. Let's talk about something that might sound a bit contradictory: a cold star. Specifically, we're diving into the world of brown dwarfs. Brown dwarfs are often referred to as failed stars. They form like stars, but they don't have enough mass to kickstart the nuclear fusion process that makes stars shine. Instead, they sit in a kind of limbo between the largest planets and the smallest stars. Because of this, brown dwarfs don't emit much visible light, making them quite tricky to spot. In recent years, astronomers discovered the coldest known brown dwarf, named WISE 08550714. This brown dwarf is located about 7.2 light-years away from Earth, making it one of our closest neighbors in the cosmic backyard. What makes WISE 08550714 stand out is its temperature, which is strikingly low for a star, around -10 to -20 degrees Celsius, or 10 to 20 degrees Fahrenheit. That's colder than the freezing point of water. To put this in perspective, the temperature on WISE 08550714 is quite similar to the winter temperatures in Earth's polar regions. This is incredibly surprising for a celestial object classified as a star. The discovery of such a cold brown dwarf has significant implications for our understanding of star formation and the diversity of objects in the universe. The existence of such a cold star-like object challenges our traditional views of star formation. It shows that the universe can create a much wider variety of stars and planets than we previously thought. Brown dwarfs like WISE 08550714 help bridge the gap between stars and planets, giving astronomers a better understanding of the processes that lead to their formation. This discovery opens up new avenues for studying the coldest and most elusive objects in the cosmos. Now let's dive into a star that has astronomers scratching their heads. The Methuselah star, also known as HD 1490283. HD 1490283 is often referred to as the Methuselah star because it's incredibly old. Estimates suggest that it might be about 14.5 billion years old. Considering that the universe itself is thought to be around 13.8 billion years old, this presents quite a puzzle. How can a star be older than the universe? This star has been known for a long time, but its age was only determined more recently. Astronomers used data from the Hubble Space Telescope to calculate its age more precisely. The Methuselah star is located about 190 light-years away from Earth, in the constellation Libra. Its age is what makes it special and puzzling. The Methuselah star challenges our current understanding of the universe's timeline. If the star is indeed older than the universe, it means we might be missing something crucial in our models of the cosmos. Some scientists think the age estimates might be slightly off, either for the star or for the universe itself. Others propose that there might be some previously unknown factor in the star's history that we're not accounting for. To resolve this, ongoing research is focused on refining age estimates and understanding the star's history. Some theories suggest that the Methuselah star might have formed from the remnants of even older stars, which could help explain its seemingly impossible age. Researchers are also looking into potential errors in our measurements of the universe's age. Whatever the case, the Methuselah star is a fascinating example of how much we still must learn about the cosmos. It keeps scientists on their toes, reminding us that space is full of surprises and mysteries waiting to be uncovered. Finally, let's explore something truly mysterious and intriguing: the Galactic Ghost, specifically the galaxy Dragonfly 44. Dark matter is one of the biggest mysteries in astrophysics. It's called dark because it doesn't emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. While dark matter is thought to make up about 27% of the universe, we still know very little about what it is. In 2015, astronomers discovered Dragonfly 44, a galaxy located about 330 million light-years away in the Coma cluster. What makes this galaxy extraordinary is that it's made up almost entirely of dark matter. Observations revealed that while Dragonfly 44 has about the same mass as the Milky Way, it has far fewer stars, so few that they account for just 1% of its total mass. The rest is all dark matter. The discovery of Dragonfly 44 has significant implications for our understanding of dark matter. First, it provides strong evidence that dark matter is real and plays a crucial role in the formation and structure of galaxies. The fact that such a galaxy can exist suggests that dark matter is not just a minor component, but can dominate the mass of entire galaxies. This discovery also raises many questions. For instance, how did Dragonfly 44 form with so little visible matter? Why is there such a stark difference between the number of stars and the amount of dark matter